In this lesson, we are required to prove that angle C1 is equal to angle A. So, here's angle C1 and here's angle A. So someone can tell that this is the chord theorem, right? So in other words, we are required to prove the chord theorem. And be mindful, this theorem is for exam purpose. So make sure you are able to prove the theorem. If you don't understand, repeat the video as many times as you can or inquire in the comment section and I will reply you. So, there is no theorem which you can prove without first constructing. When they are marking, they expect to see construction lines. So the first step will be construction. So, to construct, simply to form, right? So suppose you have got center O. We're going to say draw diameter CF, for example. You can choose any letter you want, but we want a diameter here. And that will be CF, and will be the point F here. Then the second one will be after you join A and F, or A and the letter which you have chosen. So we're going to join AF here. And there it is. And suppose this will be A1 and this will be A2. So the second thing which you are going to do here is not compulsory, but you're going to write your own required to prove statement. This is the one which will guide you if you've done the correct thing or not. So we are required to prove that this angle is equal to this angle, as we have said before construction. Therefore, we are required to prove that angle A2 is equal to angle C1. So we're going to start with our formal proof, and I'm going to erase here. Okay, so before I get started, just to make you aware of something which I have never mentioned, but you have been taught in the early grades, was that if an angle is subtended by a diameter, therefore that angle has an angle, that angle is 90 degrees. So what this means is that A1 plus A2 is subtended by diameter CF, therefore we've got 90 degrees here, right? And one thing again is that if a radius is perpendicular to a diameter, right? It's a theorem. So therefore, here I've got 90 degrees as well. C2 plus C1 is 90 degrees, and C3 is also 90 degrees. I hope it is clear. So what we're going to do here is we're going to prove our theorem, and we are now starting. So it's given that angle A1 is not given. A1 plus A2 is equal to 90 degrees. Because it wasn't given, we must give a reason why we say so. We made it ourselves, right? So the reason will be an angle in a semicircle. Feel free to write it in full, but in geometry, most cases we use acronyms. So A1 plus A2 is equal to 90 degrees. It's angles in a semicircle or angles subtended by a diameter, the way you will remember it. And again, we can say that C1 plus C2 is equal to 90 degrees, and the reason will be the radius perpendicular to the tangent, and that's the acronym you can use. Because we can see that A1 plus A2, let's do this, A1 plus A2, so let me drag this thing a bit here. So we can see that A1 plus A2 and C1 plus C2 are both equal to 90. What does this mean? They are equal to each other as well. Okay, so if A is equal to B and B equal to C, therefore A equal to C. So we can say that angle A1 plus angle A2 is equal to angle C1 plus angle C2. And we don't have to give a reason, but we can say, if we want to, just to practice, both equal to 90 degrees. But even if you don't write this, you are still fine. So you can write that they are both equal to 90 degrees. So one thing which you must do, which I have told you to always look out after, or to look out for is to look for a butterfly shape, since in most cases we have to use it when you see it. So if you check in a diagram, we've got a butterfly shape here. It's visible, right? What does this tell us? It tells us that this angle here is the same as this angle here. Okay, it tells us that A1 is equal to angle C2. So we're going to write it at angle A1 is equal to angle C2. So this means that angle A1 is equal to angle C2, and the reason is angle in same segment, right? So it's the abbreviation you can use, or the acronym you can use. So this means that in here, wherever we see A1, we're gonna plug C2, or wherever we see C2, we're gonna plug A1, either how. So I'm going to do it this way. Where I see A1, I'm going to plug C2. So if I'm gonna plug it in there, it means that where I see A1, I'm gonna say that C2 plus A2 is equal to C1 plus C2. I've got like terms, right? So if you can observe here, you will see that I've got like terms, and this is C2 and C2. So I'm going to move the like terms to the left side. So I'm going to say that C2 minus C2 plus A2 equal to C1. So C2 minus C2 is 0, and 0 plus A2 is equal to A2. And here we've got C1. So at the end we can see we have proved what we wanted to prove. We are required to prove that angle C1 is equal to angle A2, and we proved it. So at the end we're going to say that A2 is equal to angle C1. So whenever you have reached a conclusion, you can say that, okay, they said prove it, right? Prove that A2 is equal to C1. So you have proved that A2 is equal to C1, and there's nothing more to do. You just have to present your case in a clear and logical way. First thing, you must know that A1 plus A2 equal to 90. Secondly, C1 plus C2 equal to 90, giving reasons on the first step. Then third step, you equate them because they are both equal to 90. Then you're going to use the butterfly and substitute, and at the end, two terms will cancel out, and you will be left with two terms which you are required to prove. So we have proved that A2 is equal to C1. Thank you for watching.